picking back up where we left off yesterday, we had ended class with this ellipse. The bell was ringing, and I was talking about the eccentricity. Maybe you didn't get it. On your class page, I put a sample test for conics. Remember, the test is Tuesday. We're a day behind. So here's a sample test question on circles. I would suggest you try that tonight. The review is going to be Monday. I won't be here, but I'll give you a video review. We'll go over all of these questions. Here's the standard form of a circle, right? I give you the equation x squared plus y squared plus 4x minus 2y minus 11 equals 0. It is a circle. Draw the picture. Tell me the center. Tell me the radius. That's a fairly straightforward circle problem. Let's see. We're not going to be doing parabolas today. We'll do that tomorrow. Here's an ellipse problem. We're working on an ellipse right now. Okay. So here's the standard form of ellipse with a horizontal major axis. That's where we're working today. Remember, this particular ellipse that we drew yesterday had a horizontal major axis. Consider the ellipse with vertex points, focus points. Draw the picture of the ellipse. Tell me where the center is. Tell me how long the major axis is. Tell me how long the minor axis is. Tell me the eccentricity of the ellipse, which we covered right at the very end of class yesterday. And tell me the equation of the ellipse. So that's a typical ellipse problem. And on here, I've also got a hyperbola problem. So you'll have questions like that come Tuesday. This is, again, on your class page. I would look at it and start to work those questions as we go over the next week or so. Okay, so at the end of class, we were looking at this, and hopefully you drew a little sketch. So we had noted the following, that to find x-intercepts, you make y 0. If y is 0, this goes out. So you get x squared is 16. X is plus or minus 4. So there's a dot there and a dot there. Those are the two x-intercepts. The two y-intercepts, again, you make x 0. So you have y squared is 9. That gives you plus or minus 3. Okay, so that gives you these guys. I had sort of mentioned in sketching these, you should draw the box. If you have graph paper, or if the question that is given to you has graph paper, you already have the grid there. Right? So you've already got the box present. But in this case, we're sort of sketching it by hand. The ellipse is going to fit inside the box. So when you draw the ellipse, don't just connect the dots. Don't do it like a diamond and go, that's my ellipse. It's got to be round. So probably the best way to think about it is as you draw the curve, make it kiss the sides of the box. So sort of a tangent type situation, like these were circles and you're coming up, this is the tangent to the circle. And then just try to make it as round as you can. Okay, obviously it's not a circle, it is an ellipse. Now, the terminology that you need to know the vertex, first of all, major axis. That's the longer of the two, the major axis. If I said how long is that, you can just count. So 8, length of major axis. I would take lots of notes in here instead of just watching me. I know I'm going to have this and you can look at it tonight, but why look at it twice? Why not just look at it once and write the notes down so that you have the information? Okay, length of major axis is 8. Length of minor axis is this distance. Again, just count the boxes. There's 6 of them. Okay. We talked about semi-major and semi-minor. These distances are denoted by the letters B and A. The longer of the two is A. So the semi-major, half the major axis is A. Notice that this number here is A squared. And this number here happens to be B squared. Okay, so B squared is 9, which means B is 3. And you went up 3 up and 3 down. And A squared is 16, which means A is 4. So that sort of gives you the idea. And again, if you go back to the handout, again, here's my class page. if you look at this handout, I say handout, I didn't hand it to you. It's digitally there. You can look at it. We talk about lines. We talk about circles. When we go to ellipses, we'll do parabolas tomorrow. When we go to ellipses, here we are. There's two forms. There's one that has the major axis horizontal, where the a squared is under the x. That's this. The larger of the two numbers is under the x. That's this picture. If you have a major axis vertical, the a squared is under the y. So you might want to think, what would happen if you had x squared over 1 and y squared over 4? Okay, so this guy now is 2 up and 2 down and 1 over. So now the major axis is vertical. This is still a squared, and this is still b squared. The a squared being the larger of the two numbers. Okay, this is a squared. 16 is bigger than 9. This is b squared. And I did ask, sort of as an aside yesterday, what happens if a squared and b squared are the same? It's a circle. Right? It's a circle of radius a. We did that yesterday. So sure enough, let's go back to this problem now. We have a and b. And why is that important? Because the two most important points on the ellipse are the two focus points. So I gave you this equation for focus, and I sort of purposely made the c large. This equation, c squared is a squared minus b squared, gives you the relationship between a and b and the focal distance. So what I want you to think about is c is the focal distance, how far the focus is away from the center of the ellipse. Okay, so for this particular example we were doing yesterday, we squared is 16 minus 9, c squared is 7. So c is, if we're talking distance now, it has to be positive. There's no such thing as a negative distance. So the square root of 7, which we said was about 2.5. Okay, 2.5-ish. Right? Okay, so if I said, where are the focus points? The focus points are on the major axis and it would be 2.5 units away. So 1, 2.5. There's a focus point. 1, 2.5. There's a focus point. And you should know the coordinates of those focus points. That's one of the things that you should be able to do. So this is going to be negative square root of 7, comma 0. And this one is positive square root of 7, comma 0. Okay? Comments at that stage? We happy, pretty much? Okay, now right at the end of class, I gave you a formula for eccentricity. You guys were so eager to go to math that you didn't get it, but let me give it to you now. It's on the handout. The eccentricity, we did this when we were doing polar coordinate stuff. Right? The eccentricity is the measure of how much this thing is elongated. For all conic sections, an eccentricity of 0 is a circle. It sort of looks like a circle. An eccentricity of 1, anybody remember what that was? By definition, that is your parabola. All parabolas, and we're going to do parabolas tomorrow, all parabolas have eccentricity 1. And everything between 0 and 1, all the real numbers, all the real numbers between 0 and 1, all the numbers there are the ellipses. The closer the ellipse is to a circle, the closer the eccentricity is to 0. The closer the ellipse is to a really elongated thing, then its eccentricity is close to 1. Remember when we did the orbits of the planets? So Venus has the most circular orbit there is. So if you look at the eccentricity of Venus, it's like 0.001, something like that. Earth is close to being circular, but it's not. And as you go out, to the comets, those eccentricities are out here like 0.95 for like Halley's Comet. It's a very, very eccentric orbit, right? Really elongated. Okay, so how do you calculate eccentricity? The eccentricity for all conic sections is going to be C over A. So that's a formula you're supposed to know. Eccentricity is C divided by A. Now, for this example, we've calculated C, and we know what A is. So for this problem, the eccentricity is the square root of 7 over 4. Over 4. And just as a check of reality, that's supposed to be between 0 and 1, which it is, right? This is about 2.5 divided by 4. That's some number between 0 and 1. Okay? So there's your ellipse. Now, if you look at the sample test that I've thrown up here, no, but I'm going to do it Monday. Okay, so you're going to work this between now and Monday. Monday, your review, here's your timeline. Test is the 10th. The review is Monday. It will be a video review. I'll go through all these sample questions and give you the answers. Don't just sit there and go, oh, he's going to give me the answers. You really want to work them over the weekend so that you go, yeah, I got that. Yeah, I got that. No, I didn't get that. Let's get it straight. Okay, test is going to be Tuesday. If you look at this sample test, wherever it is, sample test, I've given you an ellipse problem, but it's not centered at the origin. So here's an ellipse. It says the standard form of an ellipse with the horizontal major axis is this. Consider the ellipse with vertex points and focus points. Sketch the ellipse and answer the questions. Now I'm telling you it's horizontal. I'm giving you this graph, so it has to fit on that graph. The first thing I would probably do is find the points negative 5, 0. Negative 5, 0. There. There's a vertex point. And 7, 0. There's a vertex point. Okay. And if the vertex points are at the ends of the football, could you not calculate the length of the major axis? I would hope. Just count the boxes. Can anybody do that in their head right now? All right, don't be dozing on me. 12, right. This is 7, and this is negative 5. That's 12. What is A? 6. It's half of that distance, right? So what is A squared? 36. Hey, we're getting there. We almost have A squared. We do have A squared. It's 36. Focus points. I tell you the focus points are at 5, 0. There's a focus point there, and there's a focus point there. So what does that give you? Focus points. Focus, focus, focus. It gives you what letter? C. It gives you C. What's the focal distance? Well, here's your two focus points. There's one at 5. There's one at negative 3. Well, the whole distance is 8. But the focal distance is the distance away from the center, which is 4, which gives you C squared, 16. And from there, you can get B squared. Okay, so you're going to be working this problem. There's examples like this in your book. Right? I would certainly work that problem. Ellipses and hyperbolas do not have to be centered at the origin. They're easy when they are, because the h would be 0, right? X minus h. And the k would be 0. But in this case, the h and the k are not 0. Okay, let me go back. I said I was going to do 2 problems yesterday. We got through the ellipse problem. We didn't do the hyperbola problem. So now let's do the hyperbola problem. X squared over 16 minus y squared over 9 is 1. This is a hyperbola. When I teach algebra 2, I don't think I taught any of you guys algebra 2, I always write the word hyperbola this way. And what am I trying to emphasize? Anybody? Hyperbolas have a negative sign with the squared terms. They have a negative sign. if you go to this, and I would suggest maybe you print this thing out, okay, so that you have it available and you can sort of check things off as you go. The general form for the equation of a circle, we did circles yesterday. Notice that both x and y are to the second power and that the coefficients are the same. If x and y, if A and B have the same sign but not equal, then you have an ellipse. If A and B have different signs, one's positive, one's negative, then you have a hyperbola. One of the things you'll look at on your sample test is questions like this. Each of the following, tell me whether it's a line, a parabola, an ellipse, a circle, or a hyperbola. They take 5 seconds each. Could you find the one in here that's a line? I hope. The second one is a line. How come? There's no square terms, right? Can you find the one that's a hyperbola? A parabola. We haven't talked about parabolas yet, but you studied parabolas last year. The bottom one is a parabola? No. The first one is a parabola? Yes. And this one down here, how come? One squared term. Those are parabolas. We'll do parabolas tomorrow. Could you find the circle? Circle. Which one is the circle? Circle. Anybody? This one right here is the circle. This is the circle. 8x squared plus 8y squared equals 10. Right? 8x squared plus 8y squared equals 10. That's a circle. So, this one is your ellipse, right? X and y squared both are the same sign, but they have different coefficients. That's the ellipse. And the hyperbola is this one here. So this is your hyperbola. You have an x squared minus 8y squared, right, plus 10 equals 0. That's your hyperbola. Different signs on x squares and y squares. Okay, so this is our hyperbola here, right? There's a negative there. And how do you draw it? Okay, so you start off exactly the same way as with the ellipse. I've purposely chosen these two, the ellipse and the hyperbola, because they're started exactly the same way. So here we go. In the x direction, you go 4, 1, 2, 3, 4, 1, 2, 3, 4. In the y direction, you go 3, 1, 2, 3, 1, 2, 3. You draw your box. Now, the ellipse is fitting inside the box. The hyperbola is fitting outside the box. Same box. In addition to the box, for the hyperbola, you want to draw the diagonals of the box because these become the asymptotes for the hyperbola. Now again, if you've never studied conic sections in Algebra 2, at this stage you're going, this looks confusing. But in a pre-calculus class, you had to have studied conic sections before. So this is a little bit of a review. Now, the two options that you get for hyperbolas. The hyperbolas open up and down or left and right. Ellipses go this way or this way. Hyperbolas are going to go this way or this way. They're going to open up, down, or left, right. That's how hyperbolas go. How do I determine which way it is? The easy way is just find the intercepts. Let's find the x-intercepts. To find the x-intercepts, you make y 0. If y is 0, you get x squared is 16. So x is plus or minus 4. There's two x-intercepts, here and here. Okay, so that's going to tell me my ellipse is going to be hyperbola opening this way. That's what it's going to tell me. And you're going to go, oh, but why don't you find the y-intercepts? Okay, let's try. Okay, to find the y-intercepts, you make x 0, and now you have y squared is negative 9. Right, so there's no real numbers. We're not doing complex numbers here. There's no real numbers. So there are no y-intercepts. This is the way it goes. Now, as an aside, if we had this, say we had minus x squared over 16 and y squared over 9 is 1, the box is exactly the same, the diagonals are exactly the same, but now when you try to find x-intercepts, you make y 0, there are no x-intercepts. When you try to find the y-intercepts, oh, it's plus or minus 3. So this particular hyperbola, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 4, here's your box. There's your diagonals. Okay, now this particular hyperbola, the one that we're not graphing, would open this way. Okay, like that. Opens up, down. Yeah? Okay, now let's go back to our one example. And what am I going to ask for? So I think sample test sort of makes a lot of sense. You need the center of the hyperbola. You need the length of the transverse and conjugate axes. They're not called major and minor. They're called transverse and conjugate. We'll talk about those in just a second. You need the coordinates of the two vertex points. You need the two foci. You need the equations of the asymptotes. You need the eccentricity. All of that comes together from hyperbolas. Okay, so let's look at this example. And now we'll just go down the list. Can you tell me what the center is? 0, 0. It's centered at 0, 0. That's the HK part. This one is centered at 0, 0. Do hyperbolas have to be centered at 0, 0? No, you can move them around. And the one that you've got on your practice test, I think, is moved around a little bit. Okay, so now the two axes. We have what are called the transverse axis and the conjugate axis. So let me give you some ways to remember these. I was talking with, what's her name? My brain has lost me. Who's teaching world history? Miss Erlings. I was talking with Sarah at lunch, and she said, these kids don't even know about manifest destiny. I thought they learned that in 5th grade. Okay, so history just for a minute. We connect the East Coast with the West Coast with a mode of transportation. What was it called? The Transcontinental Railroad. The transverse axis is the axis that connects the two branches. This is the transverse axis. Does it have to be the longer of the two? No. It could be the shorter of the two. The thing that connects the Atlantic Ocean and the Pacific Ocean is the Panama Canal, right? So if this was the Atlantic Ocean and this is the Pacific Ocean and this is the Isthmus of Panama, that would be the transverse axis. It can be very, very short. Transverse. Okay, so how long is that? 8. There you go, just count the boxes. The conjugate axis is the other one. It connects the other vertex points, but they were imaginary, right? Remember conjugates, complex conjugates? So these numbers are not really here. This is the length of the conjugate axis. In this problem, it's 6, right? That's how long it is, 6. Okay, so transverse connects the branches, and conjugate goes the other way. It's the other dimension of the box. If your hyperbola is looking like this, opening up and down, then the transverse axis would be this one. And the conjugate axis, it's not really connecting anything, but it's the dimensions of the box, so it would go that way, the horizontal one. Okay? So you're supposed to know those. Now, in addition to those things, one of the big keys in hyperbolas are the end behavior. What happens as you go traveling further and further and further out? And the answer is you get closer and closer to this line. It is an asymptotic type behavior. The curve becomes more and more linear. As you go further and further out, the curve gets closer and closer to this line. So it'd be really nice to know the equation of that line. So what's the equation of this asymptote? And what's the equation of this one? Well, That's actually pretty easy to do. Let me come back to this one in just a second. But let's suppose we had a point right here, and this, I'm just picking numbers out of the air. Let's say this is 8, 3. And I knew that the slope of this line, I told you the slope was equal to 2/3. Could you tell me the equation of that green line, quick and easy? And the answer is yeah. If you know your Algebra 1 now, this is pre-calculus. Algebra 1, you had the point slope form of a line, which was this, y minus y1 m times x minus x1. That, write down the equation of the line. All you need is one point, 8, 3, and all you need is the slope. So the equation of this green line is going to be y minus 3 is equal to 2/3 x minus 8. Done. You don't have to do anything more than that. You just write it down. Do I expect you to know the point slope form of a line? Absolutely. You need your point. The point is the x1, y1. You need the slope, which is the m. You just write the equation down. Now go back to here. What is the equation of this asymptote? Do we have a point on the asymptote? Well, this is probably the easiest point to choose, 0, 0. Do we know the slope of this? And the answer is yes, because the asymptote goes through the corner of the box. Right? And the slope is rise over run. How much did we go up? 3. How much did we go over? 4. So the slope of this line is rise over run 3/4. So here's the equation of this top one. The equation of the top one, y minus 0, is 3/4 x minus 0. And you're going to ask me, do I have to do minus 0? Of course not. It just so happens that this one goes through the origin. So the x1 and y1 are zeros. How about the guy going the other way? Again, it's rise over run, except now we're going down 3 and over 4. Y minus 0 is negative 3/4 x minus 0. Equations of asymptotes are very easy if you have the center and if you have the box. If you have the center and you have the box, you write these down and it takes 0 time. Just write them down. I'm making a problem up. Here's the center. It's 8, 3. Here's the dimensions of the box. I go up 2 and down 2, and I go over, 3 and over 3. So here's my box. This is 2 and this is 3. Here's my asymptotes, and I say, what's the equation of that asymptote? Just write it down. The equation of the top one, y minus 3. The slope is 2/3 x minus 8. Done. That's the equation of the top asymptote. The equation of the bottom one, y minus 3, negative 2/3 x minus 8. Got it? Quick and easy asymptotes. If you know the center of your hyperbola, and if you know the dimensions of the box, that doesn't take any time at all. Okay, focus points. Go back to our example here. Sorry, one more. Focus points. The equation for the focal distance is this. C squared is A squared plus B squared. Now, there's a little bit of irony here. A little bit of irony. This looks like the Pythagorean theorem, right? This is the one where you have a hyperbola. Hyperbola. Hyperbola with the minus sign. There's no minus sign here. On the ellipse, where you're supposed to have a plus sign, remember the equation was this. C squared is A squared minus B squared. For ellipses, we use this one. For hyperbolas, we use this one. Now, in order to make sense of this, I have to tell you what A is. On the ellipse, it was really easy. Which one was A and which one was B for the ellipse? Not X and Y. Bigger, right. The longer one was A, and the shorter one was B. Here, we don't know. It's not the longer and the shorter, because they could be the same distance. I can't say longer and shorter. I want the A to come from the positive term, and the B is going to come from the negative term. Now, I guess in some sense, that makes sense because positive numbers are bigger than negative numbers. So for this guy, let's see, here's my equation. This is going to be A squared, and this now is going to be B squared. A squared, B squared. Let me create, well, again, I think I had it at one point before I erased it. If we had x squared over 16 negative and y squared over 9 positive, this is still our hyperbola, right, minus hyperbola. Which one is a squared now? Which one is a squared? 9. So this would be a squared, and this would be b squared. So you have to think not the larger of the two dimensions, but which one is positive. Okay, so once you have that, we're back. We're trying to figure out the eccentricity of this hyperbola and focus points. So your focus point, c squared, is a squared plus b squared, and the eccentricity is c over a. Eccentricity is always c over a. I guess we have to calculate c. We already know a. Let's see. For this problem, we have c squared is a squared plus b squared, which is what? 16 plus 9? 16 plus 9. So c squared is 25. So c is 5. C is 5 for this problem? Yes? That's the focal distance. That's how far away from the center you go. So we're going to go 5 units away. 1, 2, 3, 4, and 5. Here's our focus point. Focus. Now remember again our discussion about planets going around the sun. The focus point is always inside the curve. Here's your curve. And the focus point, think about an object being bent by the gravitational well of the sun. If you calculate the focus and you put the focus inside the box, you've goofed up. Focus got to go outside the box. And so what's the coordinates? 5, 0. And the other focus point is over here, right here. So negative 5, 0. That's the focus point. And the eccentricity is c over a. So the eccentricity for this particular hyperbola is 5 over the a number. And you got to go back and look at the a number, which was 4, 5/4. What's your reality check here? The eccentricity has to be, for hyperbolas, the focus point is outside the box, above 1, right? Eccentricity is between 0 and 1 is your ellipse. Eccentricity of 1 is your parabola, and anything bigger than 1 is your hyperbola. I've told you once, I've told you a million times. That's hyperbole, right? Excess more than 1. Ah. Okay. Let's see. What, 40? We got 10 minutes. Let's go ahead and sort of start one of these problems on your practice test. I do want you to be able to do this at home. Okay? So I'm going to write this equation down, and we're going to try to get all of these things. This is hyperbola now. Hyperbola. We're going to be drawing a box. We're going to be drawing the diagonals. We have to answer all those questions about the hyperbola. Okay, so let's see. The thing that we're given is the equation, x minus 2 squared over 1, y plus 3 squared over 9 is equal to 1, and it graphs as a hyperbola. And this says this is a hyperbola with a horizontal transverse axis. So it looks like this, horizontal transverse axis. And by the by, one of the things you're going to see okay, so this is an atomic power plant cooling tower under construction. I'm not sure where this is. This is the height of a 50-story building. Now, the tall buildings at Town Center are what, 25 stories? Town Center? Yeah, 25. Weston, 25. It's twice as tall as that. Really, really big, right? World's largest cooling tower. Why am I showing you this? This cross section is a hyperbola. There's a reason why they use that shape. The construction methods using this hyperbolic cross section make it very, very easy to build. Okay, it'd be much harder to build if it were a rectangle. Much easier. And there's also sort of a physics thing. As the heat rises, the air rushes through this narrow opening, and you get a Bernoulli effect. As it goes faster and faster, the pressure drops. When the pressure drops, the moisture comes out of solution, and you get a big, this is drainage down here, you get all the water falling out of the water vapor. Okay, hyperbolas. Why do I care? Why do you care? Because here's your practice test. This test. The standard form of a hyperbola with horizontal transverse axis, consider a cooling tower with a hyperbolic cross-section. Wake up, Iggy! Thanks. Stand up if you have to. Just stand up. Thank you. That way, if you fall asleep, you'll hit the ground and wake up even faster. The transverse axis is 50 meters across, half a football field. And the asymptotes. Find the equation. Find the equation. So what's the equation of that hyperbola? We're doing that now. Here's our problem. I've got it written over there. If you wake up, you can. I'm going to throw something at you. I don't want to do that. Here we are. X minus 2, 1 squared minus hyperbola y plus 3 squared over 9 is 1. Where's the center? 2, negative 3. The first thing you do is you graph the center point. 2, negative 3. There we are. What's the next thing we do? Muhammad Ali. You got the box. You got to get the dimensions of the box because the box gives you the transverse axis, the conjugate axis. It gives you the asymptotes. You get a whole bunch of information from the box. How much in the x direction are we going? 1 in the x direction. Okay, so we're going to go 1 to the right, 1 to the left. How about in the y direction? How much we go? 3. Okay. So let me make this a little bit bigger so we can see it. The center we said was at 2, negative 3. In the x direction, we agreed we were going 1 unit. 1 unit. In the x direction. In the y direction, we're going 3 units, which is up to here and down to here. Okay. Now again, just from that information, see if you can write down these questions. Give me the center, give me the length of the transverse axis, give me the length of the conjugate axis, give me the equations of the asymptotes. You can get all of that just from this one sketch right here. Now remember, it did say for this problem, this was a hyperbola with a horizontal transverse axis. So the hyperbola is looking like this. It's elongated, heading out towards the asymptotes. Center point, 2, -3. It was the first dot you put. 2, -3. How long, count the boxes, is the transverse axis? 2. Transverse axis is the one that connects the branches. 2. How long is the conjugate axis? 6. Right? The dimension. What's the equation of the asymptote? We'll do this one here that has the positive slope first. Y minus a -3 equals, okay, how'd you get that? That's right, how'd you get it? Rise over run, the slope is 3 times x minus 2. Remember, this is the point that it goes through. It goes through that point. Now, I suppose if you wanted to, you could have used this point. That would also work. Why do I want to use the center point? Here's why. What's the equation of the other asymptote? Y minus a -3 equals -3, x minus 2. Goes through the same point, but now the slope is negative instead of positive. So it goes pretty quickly. Focus point. Well, let's get the C. C squared equals A squared plus B squared. Now, at this point, some of you are going, oh, shoot, I'm supposed to remember which one's A squared and which one's B squared. But, hey, it doesn't matter. I'm just adding it together anyway. So you're right. For the focal distance, it doesn't matter. Why does it matter? The eccentricity, remember, is C over, the eccentricity is C over A. So you really want to know which one is A. Which one is A? Is it the 1 or the 9? It's the 1. Well, yeah, this is actually A squared. And this is B squared. Okay, so for our focal distance, we're doing 1 plus 9. So C squared is 10. So C is the square root of 10, which is about how much? Give me an approximation for the square root of 10. Okay, how about 3.5? It's between 3 and 4, right? It's more than 3, less than 4. So when you plop your point down here, put 3.5 units away. Now, you've got a grid, so hopefully you're going to put it in the right spot. 3.5 units away. Here's my center point. Let's go this way because I have more room over here. So here's 1, 2, 3, 4. 3.5 would be somewhere right about here. There is one of my focus points. Remember, it's always inside the curve. You have to think of this curve as bending around the focus point. Think of this as a path of a comet. Now notice that this is fairly far away from the curve, which is consistent with the astronomy. The curve is close to the focus point is going to bend sharply. If the curve is far away from the focus point, it's not going to bend as much. Okay, so here's our focus. I need an equation. I need a ordered pair. Anybody want to give that a shot? What's the ordered pair for that Hummer? I know this one. This one we said was 2, -3. Pretty clear the y coordinate's still -3. What's the x coordinate? Not -1/2. Give it to me exactly. Give it to me exactly. What was the x coordinate here? 2. How much did I travel to the left? 2. Take away square root of 10. You move to the left, the square root of 10. What's the coordinates of the other focus point? 2. negative 3 plus, sorry, 2 plus the square root of 10, comma, negative 3. Okay. Start to work these tonight. Tomorrow we do parabolas. Parabolas are the hard ones. See you then.